would say now we are at the stage we are running 2 pilot systems, one in the Norwegian fjord and one system outside Singapore in the sea there. And we want to optimize our design. We are testing these solutions in different sea conditions, also working with naval architects and doing trials in basin laboratory. And so next steps are to improve and optimize this design for different areas and also for the different sea states that you can have either on ocean or on lakes or reservoirs. And our strategy is to continue our work and also to build larger demonstration units up to 1 megawatt units, which we would like to standardize our product on. And then in larger power plants, we will then use agglomerates or multiple of the 1 megawatt units. We are also eager to strengthen our intellectual property and continue that work in that part also. That's a good question, and of course I'm a little bit biased on that question because I'm in the business myself, but I really think it has a great future. It opens up for new surfaces for photovoltaics. The acreage or the area necessary for solar is fairly large, and those areas cannot be found very close to the consumers. You have to go further away from the large cities, etc. And then the cost of the transmission of the electricity from these plants to the consumer becomes prohibitively expensive. So I think floating solar can open up for, I really think it can be the next big thing. This is a very early phase for floating solar, and you have very many different technologies emerging. And some of the systems rely on their buoyancy in individual pontoons or buoys, where you have single modules placed on each of them, while other systems have more platforms that we have multiple panels mounted onto them. While our particular system relies on a thin membrane, a hydroelastic membrane. And technology-wise, it's also this effect of the cooling for floating solar is important to maintain a low cell operating temperature. And while most of the systems are air-cooled, essentially, our system has a direct conductivity to the water, so we can reduce module temperatures even further and thereby yield more energy out of the modules. When it comes to that particular area on the cell temperatures, I dare say so, because direct cooling by conductivity is far more efficient than air convection cooling, because the heat dissipation is more effective when contact with this membrane, which again rests on the water surface. And the modules essentially maintain the same or slightly higher temperature than the water body itself. I think one of the challenges is some of these systems does not fit directly into the existing standards, typically the IEC 61215, which regulates the installation of photovoltaic modules. And at least also for our part, it's a quite radical way to mount the modules, and I think the class societies or the regulation bodies need to get more accustomed to this and also to work out the new standards that may be needed for these new technologies. Opportunities, of course, I think are great. This opens up, like I mentioned, for totally new surfaces. You have a huge area offshore that are essentially unused area outside the ship lanes and the fisheries and other activity on the sea, but also not to mention the hydroelectric power dams and reservoirs where the floating solar has an almost ideal combination with the turbines. I think definitely the floating solar is going to be one of those. It is expanding rapidly. Market is almost exploding, I would say, with leads now all across the globe, and there's a strong demand for different systems that can deliver floating solar power. I think it is perhaps one of the, or probably the most important trend in PV.